and the one that here using hydraulics, salvo. To use salvo, we have two digging method or two excavation method here. The first one we call frontal approach. Basically, the salvo go and dig the material, and the dump truck go parallel to pick up the material out of the site, and the salvo keep moving forward to get the material. The second method we call parallel approach, when the direction of the salvo, as you can see here, go to the right, and the direction of the material to be excavated also move to the right, and the in the parallels. That's why we call it parallel approach. So with that one, we can be able to reduce the swing angles from the location of the excavation to the dump truck. When you reduce the swing, you tend to increase the capacity, because the cycle time will be reduced for the salvo. So that's one way to improve efficiencies. So as you can see, the method approach depends on the condition of the site, how we configure to reduce the swing, so that we reduce the cycle time for go back and forth of one bucket in here. So basically two methods, frontal approach and parallel approach for the salvo. To determine the production, which you will see in the next video, this is table 3.6 in your chapter 3. We also know the standard cycle per hour depends on the size of the machines, in this case the hydraulic salvo, and also the type of material, sand, common earth, hard clay, tough clay, etc. So we have here. And then, like I say, the swing angle also affect the productivity. If you swing small angle, for example, 45 degree, the adjustment factor is basically more than 1, increase 16%. If you swing 180 degrees, it reduce with the adjustment factor 0.83. It means we reduce compared to the standard at 90 degrees is as much as 70%. So keep that in mind when we improve the efficiency of the equipment. The next excavation method that we want to produce, and that in the chapter 3 as well, that is track lines. Instead of use the hydraulics, use the cable, and you can see here. So the advantage is you can get the boom higher, longer, so you can dig far, right? But because use the cable, it's very versatile, difficult to control, difficult to excavate a hard material, just like tough clay, rock, etc. So that is one limitation of the track lines, but you can go far. Like if you excavate or get the sand, etc., it's perfect to use track lines. The bucket also different. That's the way it here, there. And to improve the efficiency, you need to excavate within the conical shape from the vertical about 15 degrees. That will be the most efficient digging area for the track line, instead of go far with the cable. And the next one is the clamshells. For the clamshells, why we call it, because the clamshell bucket, as you can see here, and it also use cable, so it similar to the track lines. It will be versatile, difficult to control, but because the boom high, you can lower down this clamshell, go down, so it means that you can excavate in a deep pit, very low level. For example, if you do a shaft, which is normally used in trenchless technology that I'm going to present in the next few slides, you can use clamshell, dig vertically, go into, can be 100 feet below the grade. So all of the production equation, etc., are available on chapter 3, and I'm not going to cover the how to determine production of track lines and clamshells in the video. Now, the other kind of excavation is trenching. We mentioned about that when we work on problem 1, how to determine the adjustment for the trench. If we excavate with using the hydraulic excavator with the trench, we need to adjust for that. So there are many ways that you can do the trench. If we need an open cut, so in the area that will not disturb the normal life in the rural area, for example here, then you can do chain trencher. That's so in yes. So you can do open cut. After finish excavation, you can put the pipe and backfill. But in the real life, that might not be workable. In the urban areas, something already have on top like a road, etc. How can we do? And that is the technology. The technology come out, that is translate technology, and basically it can be classified in three methods: pipe jacking, horizontal earth boring, and micro tunneling. I'm going to present each of them in the next slides. For the pipe jacking, as you can see here, so they, for example, this is the road on top. The car keep going. If you drive it, you may not know it, but you have passed many way, past the road. Workers still work underneath of that. So here, receiving the shaft and then jacking shaft. So each pipe have one chunk, as you can see here. So keep one by one, get the material out, put the pipe in, keep going until you get the receiving shaft. So receiving and jacking shaft can be both sides of the road. On top of here can be the house, can be the car, etc. moving. It not disturb our life, and you don't have to spend the cost to resurface the road, etc. So that is the pipe jacking. You can put the pipe through the road. The other is horizontal earth boring, and in this case we can apply to install the water main or force main for wastewater pipe or cable. We can use this. So it's similar concept, but put in a borehole and put the pipe through with the pneumatic piercing tool until you get the receiving pit, and you can keep doing that. So this apply a lot in our areas. Go through the river, put the water main under the river or underneath of the bay, the seabed, etc., because we don't want to disturb the surrounding environment, coral reef, etc. And the last one is called micro tunneling or utility tunneling. I have a video here to see how it's set up. But basically, when you do a big pipe, like main raw pipe, get from the reservoir back to the water treatment, etc., then you go through the river or go through the road, you can use micro tunneling, and we have similar jacking shaft and receiving shaft that you have here. And in this case, it can be go very deep, 100 feet. And let me relate that you do the clamshell excavator earlier. So this one, they can use clamshell to excavate the dirt out, make the shaft, and then put the pipe, one pipe down here, one by one, until they go through this to finish the work. And this concept of transit technology can apply for rehabilitation or repair of the pipe as shown in this slides. So the pipe bursting in the repair and rehabilitation of the pipeline that you can see here to replace the new pipe. So with that, we go overview of the different method, different excavation equipment and the transit technology. And then in the next, I will discuss how to determine the production of the salvo. And then we move on to the last topic is the lifting, which is the mobile crane and tower crane.